Okay guys, in this last video what we're going to look at is just finding the area of an oblique triangle. And so certainly we could find the area of any right triangle or any triangle for which we know the height as long as we took like 1/2 base times height. Now this certainly does work very well for any triangle that you do know the height on, but what if I have a triangle like this here, this triangle ABC that is an oblique triangle? We don't know this height that I could drop down here, h. Well, we have a set of formulas that are actually derived in order to help us find this by using this 1/2 base times height, but in terms of, say, two sides and their included angle. And so this formula that we're going to share here is, I suppose, representable in three different ways, but it says for any triangle in which we know two sides and their included angle, okay, so side, angle, side, we could find the area of this triangle using actually these three forms of this formula right here. And so I'm going to rewrite them again, but we have area is 1/2, suppose side length B, side length C times the sine of angle A, which is the angle included between them. So we would see here's B, here's C, here's the angle A. Okay. What if we were to express this then instead as 1/2 A times B, so this would be these two sides, and that would be times the sine of C, their included angle, so AB sine C. And then our third way of representing this is A equals 1/2, and we would have A times C, which A times C times the sine of angle B. So in any of these instances, it's kind of neat that we could find the area using this formula. I just want to make sure that we can do this. And so we're going to look at a couple of instances here where we do indeed go do this. Now, in both of these examples, what I've done is, or at least what I've not done, is provided an illustration of what this might look like. So what I would suggest is we just kind of, we represent an oblique triangle here, and we'll label these out. But looking at A being 30 degrees, I kind of feel like A then would kind of be like this angle that we see right here. So we'd have A is 30 degrees. Now, in terms of B being equal to 3 and C being equal to 10, I feel like C is bigger than B here. And so I kind of feel like this should be capital C, and this should be lowercase c right here. And that this then should be capital B, and that lowercase b should lie across from it and should be the 3 centimeters that we see right here. But what I want you to notice is that we do indeed have a side angle side situation. And so you can always kind of recognize this, because as long as the two sides you have don't match the letter of the angle that you have, then that angle is included between these two sides here. And so we're going to say the area of this, simply put, is just 1/2 times the two side lengths multiplied by their sine of our included angle here. And so we would say that, I suppose that if we're doing BC sine of A, we would say B is 3. Let me get that out of there. We'll put it in orange. 3. We say C is 10, and then we have a 30-degree angle right here. So to evaluate this, we could say that, getting a decimal at least, we could put this as 0.5 times 3 times 10 times the sine of 30 degrees. But let's get our calculators here. Evaluating this, what we find out is 0.5 times 3 times 10 times the sine of 30 degrees here. What we find out is that we get 7.5. And so we're going to write equals 7.5. And one thing that's pretty important to me here is that we use this unit here of being squared units. Okay, and so in this particular case, I'm actually going to take this unit squared back. When you look at the lengths up here, okay, our 3 was in centimeters, okay, and so was our 10. Our 10 was in centimeters. When you take centimeters times centimeters, you get square centimeters. And the important bit there is just that we're describing how much space or area this triangle takes up, and so we have to measure this in square centimeters. So let's take a look at another instance here. We could go ahead and sketch our triangle out. It looks to me like C is pretty long, and so maybe I'm going to call this lowercase c here is 12 feet. And 5, you know, not very long here. Maybe I'll call this A here, so 5 feet. So if that's A, this is capital A. If this is C, this is capital C. That must leave this as being B here, and this lowercase b. But we can see that this would be 71 degrees according to the problem. So again, we have a side angle side. We can go ahead and say then our area is 1/2 the product of the two sides times the sine of the angle included between them. So we have 5, in this case 5 feet. Here we have 12 feet. And then we have a sine of 71 degrees. And so we're going to get our calculator to do this here. We'll go ahead and put in, for our half, we'll put in 0.5. Let me clear all this out. 0.5 times 5 times 12 times the sine of this 71 degree angle between them. We're going to get a total area of about 28.37. So 28.37-ish, and we would say this is in square feet. Okay, So pretty easy formula to use, but more importantly, it's more important that you know it. Two sides and their included angle, we can always find the area by finding 1/2 side times the sine of the angle included between them. Cheers.